Greetings and welcome to DevNetwork's Developer Week webinar series. I'm Patrick Gallagher, and I'd like to welcome all of you to this week's featured webinar presented by Bugsnag, Fix Bugs or Build New Features, an intro to technical debt and error monitoring. Bugsnag is a regular sponsor of the Developer Week events, and they are a full-stack error monitoring and stability management solution recognized for their best-in-class support for mobile applications. They process 1 billion crash reports per day for applications worldwide and across 5,000 industries. Companies like Slack, Pinterest, Square, and Pandora use Bugsnag as their daily dashboard. Before we get started with speaker introductions, I'd like to remind all of you to first take advantage of the sidebar where you can ask questions, chat with our speaker, complete polls, and participate and find out offers coming at the end of the presentation. This webinar will be recorded and made available after today. We'll send you an email, so you need to be on the lookout for that. Joining us today is our presenter and CEO, co-founder of Bugsnag, James Smith. Prior to founding Bugsnag in 2012, James was the CTO at HeyZap, a 3-person company that grew to the world's largest mobile gaming and mobile ads platform. Before that, James worked at Bloomberg, and he's also created popular open source projects that are used by companies like Twitter, Pinterest, and Trello. So, without further delay, please give your undivided attention to James.
Thanks so much, and hello to everyone. Interesting with the current situation everyone's in. Everyone's working from home, so if anyone hears any toddler noises in the background, I'm sure that's a familiar situation to everyone out there. But it's fun adapting to this kind of stuff. But yeah, everyone, welcome today. I'm going to be talking a little bit about striking balances between building new features and fixing bugs, and the impact that causes on the kind of mental and technical sides of software development. And the way we describe this is to, am I muted still? I saw someone in chat saying that there was no sound. Hopefully everyone can hear me okay. But yeah, we're going to wrap things up and talk about solving the drag of technical debt. So we already had some great responses in chat right now, but while I'm going through the presentation here, feel free to drop in where you're joining us from today. I see a lot of people from Seattle. I see a lot of people from the Bay Area. I even saw someone in there from Big Sur, which is probably a pretty awesome place to be sequestered at the moment. You've got some mountain air going on. But yeah, feel free to drop your questions and answers in the chat, and I'll try and keep an eye on that through this webinar. The first kind of question that I think would be helpful for me to understand and for the rest of the attendees is, which team do you work on? Are you on the product side of the company or on the engineering side of the company? Because what we're going to be talking about today has an impact on both. And in fact, one cannot be done without the other. So we're going to be talking a little bit about that. So I'd love to hear from you guys which side of the company you're on the technical side. And some other areas here that probably would help us get acquainted as well, around difficult decisions and discussions internally, mostly between that product and engineering team, about features versus technical debt. But yeah, I'm actually seeing a good mix in the chat here. I'm seeing some engineering, some product, and Ashley saying both. That's the hat I used to wear in my previous company. I don't think the engineering team at Bugsnag would let me near a pull request these days. So mostly on the product side of things. But yeah, the other kind of area I'd like to kind of help get acquainted with is this difficult question, which is really what we're going to be talking about today. Has anyone seen this tough decision, tough discussion around when should we be building features versus addressing technical debt? I certainly have. I've had a lot of difficult conversations in my career as an engineer, individual contributor, as a CTO, as a representative of the product team, and even now as on the executive team. And so, yeah, I imagine this is pretty widespread. Sounds like from chat that people are seeing this as well. While we're getting those answers come through, I'll give you a bit of background about Bugsnag and myself. If you're not familiar with Bugsnag, we're an application stability management platform. And what that means is that we detect bugs in deployed applications that are being used by your customers, and provide end-to-end reporting and analytics to help you reproduce and fix every bug. We've been around for about 7 years. We're backed by some world-class VCs, including Google Ventures, Benchmark, and Matrix. And we're operating at a scale where we have about 10 billion daily crash reports per day that we're processing through our system right now, which is a nice, fun challenge for my engineering team to make sure that they're scaling. In terms of the types of company that are using our product, we kind of run the spectrum. We have tiny little one-person shops. We have open source projects. If you're familiar with the Laravel PHP framework, the creator of Laravel and the Laravel.com website is monitored by Bugsnag using our open source plan, all the way up to huge Fortune 100 companies and products and services that you probably have on your computer or on your phone right now. You probably are using Bugsnag without even knowing you're using Bugsnag, because these companies are using Bugsnag to report back the health of their application. So let's get things kicked off with the poll. This is kind of similar to the previous question that we just had. So we've got a poll running right now, and really what we want to understand is this a conversation that teams are having? How often are you speaking about technical debt? Is this something that is being avoided? Is this something that you talk about regularly? Or is this something you only talk about in a pinch? So I'd love to see the responses to this as we go through. I think I probably know where this is going to go, but it'll be super interesting to see which direction that lands in. I'll be tracking the responses in there. But it's already kind of coming in now. It looks like that most people are landing on that option B. This really comes up when it needs to come up. Right now, it's when difficult decisions need to happen between product and engineering. It's a forcing function that tends to happen as a matter of requirement rather than something that's God and intended to. I'm not surprised by that, but actually it's a pretty even split. 25% A, 41% B, and 34% C. In case anyone's wondering, I answered C to this question because I think that's the answer for any company. Even if you are really gardening and tending to this, I think people should always be thinking about this more. So at the heart of what we're going to talk about today is this question: do we fix bugs or build new features? And this is not a binary, straightforward question with a straightforward answer. There are so many trade-offs to have here, and the reality is that everybody has bugs. There is no bug-free piece of software out there, and there's a huge spectrum here. There are applications that are running in the space shuttle or running in medical equipment that has to be incredibly safety critical. And for those types of applications, the risk of having a bug is life or death. But for most people who are writing and building software, that isn't the case. Most of the time, you're trying to strike a balance between the quality of the software delivering and getting features to market quickly. Your customers might leave if they're not getting that feature that they really need. But at the same time, if you're delivering half-baked, crappy features, then your customers will leave as well. So we're really talking about not NASA here. We're not really talking about medical pumps, embedded firmware. We're talking about kind of software that is used in a consumer environment, software that's used in a B2B environment, and an enterprise environment, that there's that trade-off between feature delivery and stability. And really, at the heart of this, the definition, this is the way I define it anyway: racking up errors for the sake of fast-paced development. That's technical debt. You're making, hopefully, an intentional trade-off. Let's get this out quicker, knowing that there's probably bugs in it still. But most of the time these days, software can be patched and updated once it's been delivered the first time. It's not like the 90s where you'd finish your Windows 98, you'd press it to a CD and send it out to Best Buys around the country. We do have the ability to see what's going on now after software has been delivered and address problems. And really, to set the scene here, everybody has technical debt. We work with thousands and thousands of companies. Obviously, it's a bit biased because they choose to use Bugsnag, so they acknowledge that they have technical debt and they want to improve it. But it's something that, for some reason, a lot of companies don't like to talk about, or a lot of business teams and product teams sometimes don't know that there are trade-offs happening. But it's worth kind of acknowledging that every single company has technical debt, and that's okay. So if we want to get a bit more technical, and again, I'll be pretty brief on this, the more formal definition of technical debt really is describing the consequences of actions during software development that intentionally or unintentionally prioritize client value or product constraints, mostly shipping on time, over more technical implementation and design considerations. Now, I put this here for completeness. This is a bit of a clunky definition. It tries to encapsulate everything, but I don't really think that this encapsulates some of the emotional sides of technical debt. So what are the impacts here? So technical debt isn't just something you're like, right, we're going to pile this into a pile in order to get this feature launched quickly. It actually has some consequences. So it slows down the creation and maintenance of new product functionality. That's kind of the most obvious thing here. But where does it come from? So I kind of break it down into three categories. There is the deliberate technical debt. Deliberate technical debt is, hey, you know what? Maybe no one's going to use this feature. This is something that is potentially a gamble for us to create. If it works, it could blow up and be really popular, but maybe no one will actually use this feature. So let's get it out to market quickly. And then if people do start to like to use it, then we can come in and rebuild it, refactor it, and start again and improve on it. That's the type of technical debt you'll see the most, typically at early stage companies or companies that are trying to be as lean, agile as possible. But yeah, you're trying to knock out features as quick as possible just to get out there quickly. You will also see this at later stage companies where there is a really tight competitive pressure. If you remember a few years ago, Lyft and Uber still head to head in the States for ride sharing. And they both launched their shared rides where you could be in a car with another passenger. I think it was within days of each other. And they'd probably both been working on this feature for a long time. It was pretty transformative to the industry, but obviously the fact that one of them launched before the other meant that the other was like, quick, hit that deploy button, get it live right now. So there's that early stage of the business, and then there's the competitive pressure. The next type of technical debt is outdated design debt, and this one is definitely a lot less deliberate. It definitely is something that happens over time very slowly, and it's kind of natural. Sometimes your product did one thing and one thing only when it started, and then it evolved into a platform, and so building it the way that it was designed initially doesn't make sense anymore, and this sneaks up on you. This is the sort of one where you just need to keep your eye on the ball and make sure that you're taking opportunities as an engineering team to pause and reflect on things. And then the last one is the bit rot technical debt. This is there was a funny story at a company I used to work for, where I'm not sure if it was a legend or a myth, but the story went that there was some code that was written to do some financial calculations, and it was a very common, I think it was like bond yield calculation or something like that. And this code was written in probably Fortran, and all that remained was the object file and the header file. So you could talk to this as long as you didn't need to run it in a new architecture, but you could talk to this and it worked, and it was incredibly fast. And no matter how many times people tried to rewrite this in C or another programming language, they couldn't get it to be as fast. So this code just stayed around forever. And you end up with things like this that are lost to the ages sometimes. But it's not necessarily these mythical stories that turn into technical debt. At least that seems intentional. Sometimes it's changing code bases incrementally that cause a problem. So a good example here would be if you added in, you had an application where there was authentication and you added in support for Teams. Suddenly you have to keep logging in with one person working and then add in support for Teams. And do you put that in the user.java or .rb or whatever it is file, or do you create a team one? Do you want to break backwards compatibility? And it just adds up over time. I call that bit rot. So there's kind of two parts that are things that emerge from technical debt: bugs and emotional drag. The one on the left, I think, is kind of obvious. We'll dive into that a little bit, but the one on the left, I think people know that this is a consequence. The one on the right, I think, is brushed under the carpet a lot. And this is the one where you'll hear people talking in stand-ups or in retrospectives when you launch a product to say, well, I'm worried that we're building up technical debt. And it's brushed off a lot of the time, but it's a serious concern. I'll dive into those a little bit through this topic. So I mentioned this already briefly, but bugs are okay. I have to start off here because sometimes people don't know how to strike that balance at all. We have a t-shirt that we wear at conferences that says you shouldn't fix every bug. And so bugs are okay. They're a natural part of software development. And you're never going to have a bug-free software product. And if you are, then you're probably moving too slow. So not all bugs are worth fixing. But while bugs are okay, the emotional drag is not okay. You end up with, I wish I had some survey results here, but it's the sort of thing that people keep very close to their chest. Maybe this is a good thing to ask in chat here. You see at the bottom of the screen, raise your hand if you've suffered from at least one of these. Sometimes it's something that people don't want to talk about, but I know for a fact that it can be very, very stressful to have to ship something quicker than you like as a software engineer. I know it can stifle creativity. I know that this can lead to software engineers and developers leaving the company and looking for that cultural environment. I'm seeing a lot of hands being raised here, so I imagine this is very common. But this is the part I think that people don't really address. People will say, well, when should we be fixing bugs? Oh, based on the fact that the CEO of one of our customers has sent an email into support, therefore we should fix that bug. Well, hey, maybe we should think about the impact this has on our development team as well. Okay, so I think core to this problem is building alignment between the engineering team and the product team. Now, the product team is quite often called the business team in some companies. I'll call it product for to be straightforward in here. But really, there's one team that's thinking about what customers want, synthesizing that information and making sure it gets built. And then there's the one team, the engineering team, that is building it and maintaining it. Obviously, there's a lot of overlap between those teams. But if you don't have alignment between those teams, you get into big trouble. Now, excuse me. The big thing that we recommend and we see is the strongest approach to understanding technical debt is to align on it. So build a partnership and have conversations around this. First off, you have to agree on the impact. If you haven't had this conversation around developer happiness, developer retention, developer productivity with the product team, that conversation needs to be had, and it needs to be had not in the last week of a project when product are trying to force you to ship it because we need to hit that deadline where the press release is coming out. It needs to happen on an ongoing basis. And if you don't have this conversation on an ongoing basis and you don't have a forum for product engineering to discuss these things, then it comes across as a reactionary thing and a reactive thing. And it comes across as an us versus them. There's pressure on the product team to ship something because there's a deadline and we've promised customers it's going live and this press release is coming out. And on the other side of things, we have the engineering team saying, look, this is a problem, but how much time and energy and mind space do engineering product have to think about it at that point? Not much, because you're trying to ship that feature or ship that product. So this needs to happen on a regular basis, and it does not need to happen while something's being shipped. I actually talk about this a lot. People often ask me, "Hey, what about in retrospectives or postmortems when you ship a feature or a product?" I actually don't think that's a good time to talk about it as well, because I feel like it can come across as defensive from both the product and the engineering team. I think if engineering wants to convince product that, hey, look, this is something that is worth working on, which it absolutely is, this needs to be something that's brought up early and often. So talking openly and regularly about this is a big deal. And one of the ways to do that is to try and metricize this a little bit and come up with a common language and come up with methods to measure the impact of technical debt. Doing this, I think, is a bit of a cheat code. You can then say, we agreed beforehand that this was our goal and this was our target, and therefore we can't change that now. So we're going to do another quick poll here. I'd like to understand how people are measuring technical debt today. So there's quite a big split, I imagine, here. I imagine the audience of this webinar probably is pretty switched on to this kind of stuff. But let's see how that shakes out in the poll. Okay, we're starting to see some early results here where a lot of people are in option C, that we are not measuring technical debt today. So I'll see if that changes, and you guys can put something in chat afterwards as we go a bit more into the slides here. I think that measuring technical debt, sometimes people don't even quite grasp, is the concept of technical debt related to things that we're doing in static analysis land, things that we're doing in stability management land? Well, actually, I think that they're really, really tied together. Okay. So 81% of you have said that we are not measuring technical debt today. That's huge. Okay, so here's the ways that I think that I talk about the ways to measure technical debt. So the first one, which I think has a decent amount of adoption, people are starting to adopt it pretty rapidly, is this concept of a static code analysis. Now, if you're familiar with products like Code Climate, or to be honest, since I started my development career, we were using static analysis, looking at the warnings that were coming out of the C++ compiler on a huge project. It used to be, these days, pretty much any piece of software, you try and aim for 0 warnings, 0 errors. But I remember this company, one of our metrics was how many warnings were output from the C++ compiler. I don't think that's a good technique. I wouldn't recommend it. But there are tools out there like Code Climate that will give you a rating and a ranking on your code base. There are things that can be early indicators of issues. The next part is a dynamic code analysis. This is a really broad category, but this basically means executing the code. Executing the code can be pre-production, testing, or production, but I think the most effective way of doing this is to actually throw real customers at the code base. Like I said earlier, it's okay to have bugs. I'm not saying you use your broad customer base as beta testers, but I am saying that the bugs that tend to be the most impactful tend to bubble up the most and tend to have help you figure out what parts of the code base have the most technical debt. The last one here is a phrase that I like to use, especially when talking to new customers or prospects. The GPM, groans per minute. So it's very tough to actually measure this, and I don't say this is a real metric. But it's a feeling and an atmosphere that is generated in an engineering team. This groans per minute is like, oh, we need to ship that next week. And you hear engineering go, ugh. And then the has a why behind it. The why is, well, that means that I'm going to have to clean up after this stuff later on. Or it means maybe I'm overworked. That's outside of the scope of this conversation. But I think it is a good metric for measuring the emotional side. It's something, again, there's no nice counter. You can't have microphones around the office to measure this. But as a manager, it's really important to have your finger on the pulse. So we're going to dig into the second one because I think the second one is the easiest one to measure. But just quickly, the first one, static code analysis, there are tools like Code Climate out there that will give you a ranking. They'll say your code base, it doesn't have bad smells in it, and that probably means that you don't have technical debt. The third one, the groans per minute, really what you need to do there as a manager is to have this as a question and a prompt in your one-on-ones. Ask your team, do you think we're doing a good job on balancing roadmap velocity with technical debt? What do you think we could do a better job of technical debt? A lot of the time, just having a sounding board is all you need. But today we're going to dive into this second one a bit more. So I want to get a bit of an idea here. Raise your hand if you're, oh, there you go. Some great, if you're in chat, there's some great suggestions of other examples of how to measure this. Yeah, raise your hand if you're using a tracking metric for actual production technical debt measurement. And one example of that would be a tool like Bugsnag that measures crashes or bugs or stability. It would be interesting to see how many people are using that, and I'll move forward in the slides while that's going on. Okay, so this is how we measure one area of technical debt at Bugsnag. So we have built something called the stability score. That sounds like a cool name, but in reality, it's a little bit more complicated than this, but in reality, it is this. You might have heard of a concept of error rates before, and really this is kind of the inverse of an error rate. I'm also using the word crash as a really broad word here. I know crash is typically used on the mobile space or desktop applications, but I use crash because it's a very easy to understand word, but really more broadly, I mean session ending exceptions or crashes or signals or whatever. So the whole category. So you can measure the stability of your application by looking at what percentage of your user sessions ended without crashing. It sounds really simple. It is that simple. And the good thing about having a simple metric like this is it's easy to understand. There's no magic involved. Like, I think one thing that product and engineering teams will agree on is that magic metrics are bullshit. You don't want to have to figure out how some company has generated some magic number. I remember back in the day that everyone was talking about AppDex, which was a performance metric, and under the hood there was all this math happening. Whereas in reality, if you want to align on something, keeping it simple means that you can trust a number a lot more. I like to call it in our space showing your workings. So stability score is what we use at Bugsnag, and it shows you what percentage of sessions did not end in a crash. Now, one of the things that we do at Bugsnag, and as an engineering team, but also in our product, is that we look at stability score on a release per release basis. So if you break down the stability of each application by version or by deploy or whatever it is, then you can see, are we doing a better or a worse job? Not only can you see that overall our goal is this, but you can see if you're hitting that goal on a release per release basis. So you can see those trade-offs that we were talking about earlier, like, hey, we've got to ship this quickly because our competitor's about to launch this feature. Well, did that screw us over? Did we end up having an awful experience for our customers based on that decision? Well, this gives you a number, and you can track it over time. Excuse me. The good thing about having a number like this, and again, like I said earlier, discuss this ahead of time. Don't discuss this after the fact. The good thing about having a number like this in place is that you can tell if you're hitting it or not hitting it. And the way that we present that in Bugsnag, and in fact, the way we recommend all of our customers think about stability, is to pick two thresholds. It's interesting, when we were building this feature, we were initially thinking, right, we want one line here. What's your line for stability? And the more we thought about it, the more we looked at other ways that people measure health over time, and the more customers we spoke to, the more we realized that actually picking one number is a lot harder than picking two numbers, which sounds counterintuitive. And it actually turned out that it's aligned with the way that the infrastructure and operations teams have been thinking about this as well. If you've ever read, and I'd highly recommend that people take a look at this book. Google wrote a book on site reliability engineering, the SRE book. It's an excellent book. It's free, it's online, and it's not that long, but it really helps you have a look at how Google think about this. One of the concepts they have is SLAs and SLOs. SLAs, I think, are going to be very familiar to everyone here. An SLA is a service level agreement. Typically, that is something that could be legally, you could be legally obligated to. Your customers may get a refund if you don't hit that. We call it in Bugsnag critical stability. We basically say, if you've hit this, then the shit is hitting the fan. And so this is a big problem. But really, that's not necessarily what you want to be looking at and striving for. That's kind of the worst case scenario. And so what we have in Bugsnag and what the Google SRE book and the SRE space talk about as SLOs is a service level objective. Now, this is something that you are trying to rally around as a product and engineering team. An SLO really helps you figure out, hey, look, we're not going to get there tomorrow, but let's shoot for 3 nines of stability, 99.9% stability. So that's the way we help kind of people think about that. And so this is kind of the breakdown. Critical stability is the drop everything and fix right now. And target stability is your SLO, and that's the aspirational long-term goal. We actually have customers that talk about these numbers in board meetings. So earlier I said that sometimes the product team is known as the business team. Well, really, the product team is the one that has to go in front of the executives and the board and say, here's why we didn't ship this feature on time. And so they get their feet held to the fire a little bit. And so having this alignment early means that you can have conversations. One of our customers, in fact, had a board meeting where they said, hey, we can't launch this premium feature because our stability score dropped below our target. And therefore, we've agreed as a product and engineering team ahead of time that if we ever don't meet the stability goals in our product, then we pause on the roadmap and all of the engineering bandwidth, or most of the engineering bandwidth, goes into fixing these underlying problems. And that's the right time. That's the opportunity to clean up this technical debt, because looking at your stability score means you go one layer deeper and say, these are the top bugs. Looking at those bugs allows you to look at the stack traces and the code base and say, oh, wow, no wonder this file has so many bugs in it, because this file's been around. I've seen, I remember working on a Ruby on Rails code base once that had a file in the models directory called user.rb. And this is a company that pivoted 3 or 4 times. And so the user.rb had been around since the beginning of the company, and no one had ever deleted a line of code or a method. That's bit rot right there. That was a mess, that file. But it's a good opportunity to say this file is a big cause of these problems. Let's go in and address. So one of the things that I think that people ask us a lot is, how do we figure out how to set these scores? The short answer is pick something and adjust it over time. But really, I think that people want to figure out how to set these aspirational scores in particular. So I figured I'd share a bit of data. Now, this is one type of application, but I thought it was interesting. Consumer mobile applications. We have a lot of customers in the consumer mobile space. And we looked at applications that use Bugsnag that had a high App Store rating, more than 4.5 stars, and a broad spectrum of usage. So from hundreds of thousands of crashes per day to several million crashes per day, or just sessions per day, sorry. And at the lower end of the spectrum, the worst end of the spectrum, these applications had a stability score, a crash-free rate of 99.6%. So again, if you're thinking about SRE land, you'd call that 2 nines of stability. And at the high end of the spectrum, we were seeing 4 nines, 99.99%. And just to give you an idea of the distribution of this, 80% of the applications that we looked at had crash-free rate higher than 99.9%. So really what we're saying is the worst apps that had high app ratings were at 99, 2 nines of stability. The best were at 4 nines, and the median was at 99.9, 1, so 3 nines. So it kind of gives you a bit of an idea of how broad this spectrum is. You'd think maybe this would be up at 5 nines, like uptime and availability. Not true. So there's our recommendation of starting point. Set your critical stability to 3 nines, set your target stability to 4 nines. Right, so really, if you can measure, you can align, and then eventually stabilize your product and improve technical debt, you can move away from being reactive, listening to annoyed customers. That case study I said earlier about the CEO calling up and saying, it's broken, you need to fix this one bug, to being a collaborative joint focus. And I think that's the way to build this collaboration. I just saw in chat here, Ashley, thank you for linking that. Ashley's linked the Google SRE book. I definitely recommend reading that. And I'll see if I can pick up some questions in the Q&A at the end. So really, takeaways here. Bugs are the consequences of a consequence of innovation. So it's good. Bugs are good. Just make sure you're measuring them and understanding the impact of them. Technical debt is never if, but rather when. There's only so many pieces of trash you can throw into the back seat of your car before you need to clean the back seat of your car up. But you just need to know what's acceptable for your business and your teams and what's healthy. And stability scores help align teams around technical debt. And I say stability scores because that's our case study we used here, but some kind of production measurement means that you have a number that you can agree on. Or pre-production if you're using static analysis, but look at a number, put it as a KPI, have that KPI be shared between product and engineering, and then hold yourselves accountable to it. Because if you do that, you move from coming back to these conversations when everyone's angry and stressed and emotional, and you have these conversations on an ongoing basis when you can actually do something about it. So before we move on to some Q&A, a little bit of a selfish, self-serving thing that we wanted to talk about here. We've talked about stability scores. We've talked about measuring technical debt. That's what Bugsnag does. That's what our product does at its heart. That's why we were passionate to build this business in the first place. But something that we're launching in the next couple of weeks, we're quite excited about is our where are we here? Our workflow and automation engine. So there are situations where you want to be reactive and responsive. There are situations where you want to balance stability with a roadmap delivery. But what we found is that people want that not only in a nice dashboard, but they want that delivered to them in Slack or an email or in their Jira tickets or whatever piece of workflow that you're using. And so we've always had some kind of way to do that in Bugsnag, but we're kind of leveling that up in a big way in the next couple of weeks, and with what we're calling our alerting and workflow automation engine. So what this allows you to do is to be a bit more precise about how you understand where bugs are happening in your code base. So you can create bookmarks based on properties of an error. You can say, look, this error happened to a VIP customer, or this error happened in the payments page, which is a very important page for us, or this error happened on a sign-up page, or this error happened in this A/B test or experiment. Whatever runtime properties you have, you can tag errors at runtime with those properties automatically in Bugsnag. And then now you can subscribe to alerts or automate your workflow based on those properties. Now, a couple of examples here are, you can have an email go out to your product team or customer success team when your highest paying customer sees a bug. Or you can have a Slack message go into your front end channel when a bug happens in a particular page in your front end code base, or maybe in your entire front end code base. If you have a mono repo, maybe you want to say, look, actually, my team only cares about this part. So now using these filters and bookmarks and setting them up in our automation engine and our workflow engine, you can get those precise alerts and notifications. You can even automatically create tickets in Jira when errors hit a particular threshold. So you can say, look, like I said earlier, bugs happen, it's inevitable. So we're just going to, for a high volume consumer app, for example, maybe if they happen 1 or 2 times or to 1 or 2 customers, it's not a big deal. But if they start happening a lot, let's create tickets in Jira. Let's have that happen automatically. So that's coming out in the next couple of weeks. So keep an eye on our press release and on the Bugsnag dashboard for those new features. Right. Thank you for your time and questions and attention. Really appreciate it. Now's the time to kind of throw into Q&A. There's a Q&A feature in the tool that we're using here for the webinar. There's a few questions coming in already at the moment, and I'm gonna go through a few of these right now. Okay. I'll kick off with this one right here. So a question is, how can you give us a specific use case, an example of how one of Bugsnag's customers use search and segmentation? So in our product, I just kind of set up with notifications. We have this way of not just looking at a big bucket of bugs. You can search and segment bugs based on key properties of an error or a customer. I can't say the name of the company that's using us, but one of our customers makes mobile games, and one of their the players of their games is a very famous celebrity that is on Instagram a lot. You can probably take some guesses. And this celebrity spends a lot of money on this platform. And they have set up an alert, and they have an account manager for responding to any of these bugs. If this particular celebrity saw a bug in this application that they're spending a really large amount of money in, they're going to go on Instagram and start saying, "Oh, this game sucks. I used to love this game." You want to protect that brand. You want to keep that revenue around. So I thought that was an interesting use case. This customer has set up a bookmark in Bugsnag and an alert to let their teams know when this famous celebrity is seeing bugs in their application, which is such an odd thing to do. It doesn't really align with technical debt we've been talking about, but I thought that was a cool use case. Okay, let's see what's coming up next on the Q&A here. Another question here is, here we go. How do you set up a culture of stability management and application health across the engineering org? Okay, this is a good question. It's a tricky one, especially if you're not used to doing this. I've been in big companies that don't give a crap about this, and it's an uphill battle. I've been in small companies where this has been important since day one. The way that Bugsnag builds Bugsnag and builds software is this is something that we care about from day one, so it's a lot easier. But if you're trying to bring in this culture of managing and balancing technical debt using something like application health, stability management, static analysis, the best way you can do this is act like a salesperson, and don't do this when, like I said earlier, when shit's hitting the fan, because people won't be listening to it. Act like a salesperson. It sounds really odd, and I know it's unusual and difficult for a lot of people with technical backgrounds to do. But there's a movie, I should share this afterwards. There's a movie called Last King of Scotland, and there's a great scene in there where this guy goes, "But you did not persuade me, Nicholas." And so it's easy to moan, it's easy to complain. But if you can take a pause, think about why you're complaining, and add one extra layer on top of that, then things are much more well received. So as an engineer, really, I'm talking about here, who I think mostly have engineering managers mostly have the uphill battle to focus on this kind of stuff. Take some time to look up some statistics. Take some time to look up the real emotional impact of this. Take some time to look up surveys. Do a survey in your organization to see, if you feel like that people are at risk of leaving the company due to technical debt. Take a look at what you can get out of the benefits of having a balanced and stability score. For example, you can increase roadmap velocity. There's plenty of studies out there that you can look up. Take that. Don't necessarily build a huge presentation, but just say, "Hey, I think we should do this. I'm going to champion it. And in fact, I'm going to start measuring it. The reason I think we should do this is X, Y, Z." So it's hard because inertia is the hardest barrier in companies. People do things the way they're used to doing things, not just in companies, in any group of people. So if you care about this and you want to be the champion for this, do a little bit more than the the basic, I think we should do this. Take it the extra mile. Go and do a bit of research. Go and get some stats, and then present that in your lunch and learn. Present it in a one-on-one with your manager. Sit down with the head of product and say, I've got some ideas of how we can increase roadmap velocity while not sacrificing on technical debt. So you have to become a champion. Like I said, you have to become a bit of a salesperson for this. So it's not a game of complain. It's a game of be proactive. Okay. Great question here. How would you generate stability score for design debt versus code debt? Would stability score not be more tuned towards code debt? Yes, absolutely. And kind of this is what I was touching on earlier with dynamic versus static analysis. I'm biased, obviously, but I tend to look more towards the right-hand side of software development and look at things that are causing customer-facing issues. And the reason I talk about those a lot in technical debt, because I think it's the easiest ones for the product team to understand. So if you're trying to build that relationship between product and engineering, it sounds awful, but the product team care about the health and happiness of the company, but maybe they're not thinking about the groans per minute that we were talking about earlier. That's not something that they can get their teeth into. But a product team care about customer experience and stability score and measuring the impact on customers' experience is something the product care about, and it also aligns really well with technical debt. If you want to look at the design debt side of things, which I do think aligns more with the groans per minute, you'd have to take the finger on the pulse, do one-on-ones, do surveys, develop a survey, set up a Google form, and just run that on a regular basis. But also, I actually think that the static analysis programs out there, if you want something more numerical, then I think static analysis tools are much, much better at doing that. If you run static analysis that generates a percentage score or a grade like Code Climate A to F, then you can then align a target around that. So I think design debt is really hard to measure in a production environment because it's almost a black box once it's live. So I think it's much better to do that using static analysis. If you look at tools like Code Climate, I sound like a salesperson for Code Climate here. It's a cool product. It will show you things like, are there copy-pasted chunks of code? Like it has heuristics that they called code smells, and so it detects code smells, which I think help you figure out design debt. If you've got one particular team of developers that's copy pasting functions all over the place, you're in trouble. So great question, thanks, Anis. Okay, let's see if we have some time for more questions. Here we go. How does Bugsnag use Bugsnag? It's kind of funny. We use Bugsnag on every single repo, every single application in our stack to detect the health and stability of our applications. One interesting thing, I'll talk about how we use it. We have stability targets, we have stability goals, and we try and keep what we call inbox zero. So it really varies between our engineering teams, but ideally we try and keep our Bugsnag projects to inbox zero. And the way we can do that is not by fixing every bug, but using the features that are in Bugsnag, like snoozing errors. You can say, look, I don't care about this error, only tell me about this when it happens X more times, or if it happens after this outage is finished. We also mark and sweep things into Jira. Once we've decided that a bug and triaged it in Bugsnag is worth fixing, we'll click a button in Bugsnag that then synchronizes that into Jira, and then keeps a link between those two tickets. So on a day-to-day basis, that's how we use Bugsnag. A little quick aside, which you guys might find interesting, because detecting bugs in Bugsnag could be an infinite loop generator. If you've got a bug in Bugsnag, that sends a bug to Bugsnag, which generates a bug in Bugsnag. Oh, I sound like that exhibit meme. But what we've had to do is we've got our Bugsnag.com SaaS product, but we also have an on-premise version of Bugsnag, which is basically just Bugsnag that you can install on your own servers or infrastructure. So the version of Bugsnag, the cloud version that most people sign up for on Bugsnag.com, doesn't report bugs to itself. It actually reports bugs to a version of Bugsnag on premise, which is typically a week to a month behind our cloud code base. So we've had to do some clever things there to make sure that we don't cause any bugs causing bugs causing bugs. So hopefully that answers the question there. Another great question here. How do you characterize between compiler and runtime error bugs versus visual bugs? Visual bugs are harder to quantify. Oof. Now, there are tools out there. I forget the name of the one I've seen recently that will give you effectively unit tests for UI. So I think there's one called there's one called Percy, Percy.io. They have a little Percy pig as their, oh no, it's a porcupine as their mascot. So Percy.io tries to solve this problem by giving kind of visual diffs ahead of time. So they'll help you understand what changed and highlight that very clearly. So that is, I think, a good way to do things. Another thing to do is actually look at trailing indicators. A bug that we had at my previous company, we had an issue where it was really subtle as well. We changed something that adjusted a session token, and it meant that it logged everyone out. So everyone who was previously authenticated in the application got logged out. And this is not quite a UI visual bug, but it is a bug that I think doesn't cause a crash, which I think is maybe what you're getting at here. There are bugs that are like an on-click handler wasn't hooked up to a button, for example. But in this case, everyone was logged out. And the way we spotted that was we noticed our metric for number of people who signing in skyrocketed. And so we were like, oh, wow, there's loads of people logging in today. Maybe we've got more signups. And when we looked at it, we were like, oh, crap. This is a pretty bad bug. We've logged everyone out of the application. The other example I give, which is, I guess, a UI bug, which is closer to your question, is detecting things like a button that doesn't have a click handler attached to it. That's not going to cause an exception. We've just forgotten to hook up the click handler. So there are things you can do, and we wrote a blog post on this about detecting user frustration. So if you've forgotten to hook up a click handler, then what behavior is going to happen? Well, probably people are going to be smashing the mouse button on that button. They're going to be hammering the click button to see if it will work. So actually, there are things that you can do to detect that. And we've got a code snippet in this blog post, but you can detect frustrating experiences. And so having a look at really frequent clicks on a particular DOM element in the browser, that's a really good way to detect it. Another thing you can do on single page JavaScript applications, JavaScript stuff comes to mind right now because this is what we wrote our blog post about. But if you have a single page JavaScript application, you can detect if people are doing Command R, hitting F5 to refresh the page. You should never have to refresh and pull down a single page JavaScript application. So if you did, something's probably gone wrong, and then you can come into like a Bugsnag and look at what happened to cause that. And in fact, you could hook up to that on exit event, flush that data out to your Bugsnag system, and then look at the last actions that user was trying to do. So that's I think, a good way to characterize opportunity. There's a bit of a long answer to a short question, but hopefully that covers it. I think we have a time for one or two more questions here. Question here, who owns stability management in your customers' organizations? So it really varies. We're seeing the emergence of a couple of real champion teams. My favorite one to work with is the observability team, especially client observability teams. Observability is a new kind of concept. I'm not sure if it's really well defined yet. It's one of these sexy buzzwords like Agile was a few years ago. But the idea is it's a team that is dedicated to measuring and responding. And client observability I like a lot more because it doesn't just mean we're observing some performance number like backend observability typically does. It looks at user impact a lot more because client observability touches the customer. So observability teams, I think, are a great team to own. Most companies don't have observability teams yet. Another new emergence of teams that we're seeing is release managers. Release managers are the people who click the deploy button or click go from rolling out an A/B test from 5% to 100%, and things like beta to production promotion of builds. Release managers are really good champions for this, but most companies don't have observability teams. Most companies don't have release managers. So what we're finding is the people who own it typically are product or engineering, depending on who wanted to pick up the baton first. Companies have had it for a while, typically will have it on the product team. But given what we've been talking about today, actually a lot of people are starting to push to have this from the engineering side. Okay. Any other questions coming in here? Great question here. At what point do you determine you have too much tech debt and it's a stop on a feature development until tech debt is addressed? Okay, so like I said earlier, the ones that are going to be the most impactful are the ones that have customer impact. So code climate and things like this, I think, are really good ways to stop code from being pushed out to production before it gets too tech debty. But really, because that conversation of stopping development has to be a discussion between product and engineering, unless you're hacking on the first version of something. It needs to be metricized. So honestly, the example I gave earlier of setting an SLA, stop and fix things number, using stability score or some other metric of real customer impacting technical debt is the only way I've seen this be practical, because everything else is too squishy. It's for me that number is the best balance between what product care about and what engineering care about. And the only way that you're going to be able to justify to management and to the board of directors and to the investor, whoever, is that this is the right thing to do for the business, short term and long term. So I think setting an SLA, picking it at a reasonable number, and then if you go below that, there should be no debate about if you should stop development and work on bug fixes. Okay. All right. So I think we're about at time here. I appreciate all the thoughtful questions. It's been great talking to everyone, and I'll talk to you soon.
James, thank you very much. I know that this is Patrick Gallagher. There's an offer that just popped up for all the attendees. Please make sure to take a look at that. Thank you, James, for a great presentation. A lot of interaction, a lot of participation by the attendees. And then before we end today, I'd like to remind you all that the webinar has been recorded and made available and will be made available tomorrow. So you'll be able to view the webinar again and also potentially share it with some of your coworkers. We'll be sending you an email once that recorded session is ready and available. And you'll also be able to find that recorded session as well as other sessions in the webinar archive at developerweek.com. So I wanted to say thank you to everybody for coming to today's webinar, and please stay safe and have a great day.
See you, everyone.